Okay. So I'm having just two lessons now. How are you wearing?
Hey, Mr. David, good evening, sir.
Yeah, good evening. How are we doing?
Doing fine, brother. Welcome back.
Yeah, thank you. Thank you. I welcome you to.
Justice, good evening. Thank you. People don't take one market.
Yeah, yeah, of course, of course, of course. Okay, so you were actually waiting to join by exactly 9 o'clock with us. Okay, okay. So this is the big thing. Hey, Sebon, please help me mute your mic. Okay. Thank you very much. So I'm happy to have everybody again, man. It's always awesome to meet great minds like this. So as usual, before we start anything, I'm going to give a shout out to those that came very early. And this includes Justice Obasi was the first to be here. Yeah, I met him here already. And then we had Umedi Mo in our midst. Women, I welcome you again, and Justice too, I welcome you. Okay, then I had Ezebong.
Thank you very much.
Welcome. Then I had Ezebong. Ezebong, if you are there, please unmute your mic and say hi.
Hi, I'm here. Hello, good
Okay,
evening, everyone.
okay.
Come
Now,
on, I said justice no get house, so those of us who no get house, now why you meet her here.
Hmm.
Ezebong is doing well. He's very excited to be here. I can hear it from his voice.
I'm so
So,
excited to be here.
okay, that's good. Pascal, I'm seeing you. Picasso came early, Soft Gabriel came early, and all other people that just joined. I welcome you again to the meet. We've missed it for a day, and it feels like it's already a week. So imagine when we miss it for 3 days, man. That's like a month. Okay, this is great. So before we start, I always want us to discuss about what we've done last. Okay, so before we start, I would love does anybody have questions or areas you don't understand? I have a book here where I jot down these things. So if I get particular amount in this side, then we might go back and look at it to be sure that everybody's on the same track. Okay, so does anybody have any questions or areas where you're having confusion, whatever is troubling you now? Let's say from when we started till now, please. This is time for you to speak. You can raise up your hand or give you the chance to speak. Just whatever is bothering you at all from the beginning of our session, data types and variables down to your now that we are about to have recursion. So please, if you have questions on anything or where you're finding it difficult, including our present projects, you're finding it difficult to please raise your hand, I'll give you the chance to speak. Okay. So who made him up, please?
Oh, okay. Thank you very much. Though
Okay.
I'm not 100% sure about this my question because it's something that we were going through before the printf, and the printf is kind of like exhausted so much in me that I don't even know what I know anymore from before. But truly, before the printf, with discussing functions, I haven't still been able to get a very good grip on functions. I know I cannot ask you to go through the whole class again, but really, as I would love it if you keep it in mind to please, if possible, at some point in time, to give me a refresher program on that particular functions of the thing again.
Okay. There's no
I
problem.
still not clear with functions generally.
Okay. There's no problem. There's no problem. So, about functions, definitely we've not even started with the functions. What we did that day was like an introduction, and then everybody got to enjoy the class with the tasks I gave out. We've not even started functions. So the way I stretched the class was that we were supposed to create function. I was thinking that function was going to take just only that day, but unfortunately, it seemed like it was a long course on its own. So we've not started. Okay, we're still going to have sessions or on session or function. So I told us that I've mapped out the whole class. So that was why it's like this. I've invited um, our guests already. So I could not and also we had printers that scattered the whole thing. So we could not shift the classes out or of all, we just had to go on with that because we already put people down. So after today, we'll go back to functions and also print F because I believe we are not yet done with that. So are you clear?
All right, thank you very much, sir.
Okay, there's no problem. So our guest is already in our midst. Okay, he's already here with us, and I tell you, tonight is going to be a different night for us. Okay, so this is someone I respect so much. Yeah, he's a highly experienced and respected professional from cohort 8. Yeah, and we are honored to have him here with us today to share his knowledge and um, expertise. So I tell you, he brings with him a wealth of experience and passion for the whole thing. And I'm confident that both me and you are going to find informative and will find me informative and engaging. Okay, so my teammates, please join me in welcoming Mr. Boluwatife Session.
Yeah, good evening, everyone. I hope that's not much of an introduction.
Thank you. That's okay. Thank you very much, sir.
Yeah, I hope everyone can hear me clearly.
Please, we can hear him. Please unmute your mic and say hi.
All right.
Okay,
Good evening,
I can
everyone.
actually hear you.
All right. Hi. So let's continue.
Hi, I can hear you.
Yeah, evening. Let me share my screen.
Yes, sir.
I won't be able to. So there's no lighting. I won't be able to show my face and all that. But let's continue. So I hope you can see my screen.
Yes, sir. We can see your screen.
All right. So we're having recursion, and let's just we try to start from the basic because to understand every complex thing, you have to start from the smallest explanation possible. So, recursion in C. What is recursion or what does it entail? Let's see. Recursion is a technique in which a function calls itself repeatedly until a certain condition is met. It's like a way of solving problems by breaking it down into smaller and then sub problems and then combining the solution to find the to this combining the solution to those sub problems to find the solution to the original problem. Recursion is like stacks. I don't know if you know what stack is. It's like a usually it's like a stack algorithm kind of way to solve problems because you just put things on top one after the other and they repeatedly call them. So that's what recursion is. Now let's see how to implement recursion. How do we implement a recursion or how do we get started with it? But note first, to solve a problem with recursion is like solving a problem with a loop. If you can solve a problem with a loop, not all problems, but if you can solve certain problems with a loop, then certainly you should be able to use a recursion too. What's the general syntax of recursion? I hope you can see the slides. Now this is the general syntax. You have the function name, the argument, the return type, and then a base case. A base case, and then the recursive case. The recursive case is the one that is, recursively calling itself again, and then the base case is the check. It is the check you place to stop the loop in case to, overflow or something like that to break the loop at a certain point. So the next slide. Now, how to implement recursion? First, to be able to implement recursion, we should know how to implement a loop in C. And then the loop now, let's check the basic structure of a loop first. Now, a loop is divided into usually four parts. You have the initializer, the condition check, which you can also call the base case, and then we have the execution, and then update that something like the recursive case. So let's illustrate this. Let's check what a for loop is. Now this is an example of a for loop. Um, this is an example of a for loop. What is loop doing? This is we are trying to print this string recursion. This is a string here, just a recursion. So we have the initializer, which is int I equals to 0. This is the initializer for the for loop. And then we have the case, the condition check, which we can also call the base case. This is the condition check, and it is what? I less than string length of what? Recursion. That is, up, it will break once once I is greater than the string length. And then we have the I plus plus, which is the recursive case, the update. Once the loop goes on and goes on, this keeps updating. I plus plus. That's the update. And then this is how a for loop is done. The initializer, the base, and then the base case, and then the update. And then we printf %c recursion I. Once it is printed up to n, then it will surely break. Now let's check this version again. Let's check the while loop to see. And this is another while loop, another loop. This is while loop. It's almost the same as for loop also. So let's see, we have a recursion, the string, and then we have an initializer again, which is I equals to 0. And then the case, while I is less than stringlet recursion. That's the case, the base case. The base case is always the case to check on every step of the recursion or any step of the loop. So this base case, and then the update, which is I plus plus, which is after every execution of that loop. So we have printf %c recursion I plus plus. I hope this loop was understanding enough. So now let's check. Let's go deep into recursion itself. Note that these two loops, they all print the same thing, which is the string recursion. Now let's try doing the same thing with recursion and not loop. Now solving the problem using recursion, if you are a fresher, a recursive function again is basically a function that calls itself. It calls itself repeatedly. And like a loop, a recursive function, it also has the initializer, it has the base check, the condition check, it has the execution part, and then it has the update, the iterator update. It's the same thing as a loop. So let's first declare a recursive function to solve the problem of printing that string recursion. Let's go to a compiler to do this. Okay. I hope you can see this tab. Now this is my recursive function. Let's just cancel this. This is the recursive function here. We have the void, print recursion, the string length, and then I. This recursive function is the void function because we are not returning anything. We are only trying to print the string recursion. To pass in the string, we need to make this recursion. We need to make the parameter to pass in the string to print, and then we also have the string to use as the base case, and then for the length of the string, we pass the initializer, the int I, which we'll be using as the iterator object. Now let's start writing this. So here's the arguments: recursion, length, and I. So what do we need to do first? What can we do here? from our previous explanation, we need to, for a recursion to be a recursion, we need the initializer, the base case, the execution, and then the iterator update. So now let's print. I hope this is not disturbing. Right. I hope this is clear now. So let's print the recursion string first. We are going to print it char by char. Then recursion percent %c, that is for char. Recursion I. Printf I percent %c recursion I. Now this will print each char of the string of recursion. Now after printing, what do we need to do? We need a base case. We need an iterator update. This here is the execution. We still need the base case and the iterator update and then the recursive case, of course. So next, let's increase I. Since this is after printing this, we need to increase I to print the next one. So we put I++ to increase I. And then we check this base case. Let's have a base case. We check if I is equals to string length, which will be the argument of the length of the string. So once I is equals to string length, we need to stop the execution. We need to print, let's print F, new line, and then break. And to break in a recursion, you don't need break, you just need to return a particular thing. But in this case, this is a void function, so we are only going to return. We're not returning anything, but just return. So this will stop and break the loop. Now we have a base case. You have the base case. You have the execution, the iterator update. Now what do we need? We need the recursive case itself. So now we have the function to call itself. This is the function. What do we call it with? We call it with the first argument, the recursion string. Then the string length. Now, and then I. So this is all. This is the recursive implementation of the string printing function. Now let's call this function from main. How do we call the function from main? We need this argument, the I, string length, and the recursion. So int I now. Say the recursion string will be recursion. Use a capital R here. So let's leave like that. And then we call this recursion function. Print recursion. We pass in our string, the length, string length. This is string length of recursion. And then finally, I. What are we going to put here? I should start from 0, of course. 0 here. This is 0, 1, 2, 3, 4. That's how this is represented in C. So we say I. Oh, sorry. So this string length function in I equals 0. So this is everything. Let's try to run this code.
Excuse me, sir.
Yes.
Okay, please help us zoom in your screen.
All right. We already have some errors now, so let's try and check these errors. I hope this is enough.
Please zoom in a.
Is this enough?
Yes, I think this is enough.
All right. So we already have some errors. Let's try to check this now. We have expected expression before char, line 15. Expected expression before char. Does anyone know what we are missing here? Sorry. Does anyone have an idea what you are missing here? It says expected expression before char star recursion and then two few arguments to function.
I think you're supposed to put int before the string length and I.
Int before the string length and I.
Yes, that was how you call the function. I mean, in line 5, there was an int before string length and int before I. And you omitted it in line 15.
No. Oh, yes. Thank you so much. This is the error. Yes, line 15. The error is this. I'm not supposed to pass this back. This is like a declaration. No, we are passing this same recursion string. So I'm just going to pass recursion, not just that recursion. So I think that's the error. Let me try rerunning this. Yes. Now we have the string recursion. Now this works. So let's review it again. The recursive function, the argument, string, recursion, the length, and the I. The I starts from 0. And then on every loop, it will print %c, recursion 0, R. It will increase it to 1. I now is 1. Then it will check, is this string length, is it up to the length of this recursion? It is not. So we go here. Then it calls itself again with the same string length, but now I, which is 1. You've increased I. Now this is how this recursion works. Does anyone have any question? Let's check this again with some other words. Let's just check C is fun. It works. So does anyone have any question regarding this one? Or should we move on? Any question regarding this recursive case? Yeah. So let's check another implementation.
Hello.
Yes.
Yeah, I don't know if you can just go over it again from the very
All right.
part where you actually call the function. Just
All right.
little
For me,
explanation
right?
a little bit. Yeah.
For me, okay. Let's just say this here is the initializer, because a recursive function, it can't call itself from the beginning. It needs something to call it. This here is the initializer. We're calling it from main. So we initialize it with the string recursion, the length of the string length, and then the I, 0. And then in the function itself, this is the function itself. What does the function do? It takes the string, it takes the length, it takes the I, which starts from 0. Then on each execution, this is what happens. It prints the string received from I equals to 0. So it will print and present C. This is a chart to print each character in the string. So let's say I was 0, it will print this recursion 0. And then it will return the first letter of the string. And then it will increase the I, to increase the I, which now will be 1. So it will check now, this is the base case. Is I equals to the length of the string to break it or to continue. If it is not equal to the length of the string, it will skip this. And then it will call itself again. It will call itself again with the same string. But now with a new I which is now 1. I is 1 here. Now on the next loop, it will go again. It will to print the 1. It will increase it to 2. Then it will call it again with 2. And then print 2, then 3, then 4, then 5, then 6, then 8. Let's say 8 is the length of the string. Then it will check is I equals to string length. And if that is true, it will print the new line and then it will return. And then that's it. It will break the loop. So I hope this was understood.
Yeah, that was quite understandable.
All
Now,
right.
my major challenge there is when we're declaring the function, the first
Yes.
function, we actually pointed like the character, right? The character that is carrying a pointer there. So I think that's where my confusion actually comes from. Is it because
Oh,
it's a string that's why you are using a pointer there?
a pointer. You mean this?
That yeah, the pointer there, yes.
This is how to. You have two ways of um of declaring a string. You can either declare this way if you know the length of your string, or you can use this way. Not exactly a pointer. It is more of the generic way to declare a string, because this is
Okay.
what they call it. Um, what do they call the word? But this is not exactly a pointer.
Okay,
It's
like
a pointer, but
the second one I'm seeing there is the character array, right? Like if you
no,
know
it's a string.
the string, okay, yes.
If I didn't input the size, then it would be a character. But I
Okay.
input the size. But I didn't know this size. That's why I just used this. If I knew the size, then let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. So if I know this size, then I'll just put
You
it
can
in.
declare it this way. You know the
Yes, I
size.
can.
Okay.
Let's try it this way. Recursion. Then let's do it this way. Okay, we have a problem here. So recursion 9. Uh, okay, the semicolon. All right, let's try. So it works the same way.
Okay.
It works the same way. So I hope this was understood.
Thank you very much. That's very, very clear.
All right, let's continue now. So in the recursive function, it is
Wait, sorry for disturbing you guys. I've raising up my hands as well, but maybe you didn't see me.
oh, I was not checking.
Okay, so I've been checking the function, but I'm meant to ask that what is the main purpose of the recursive function?
What did you say?
As in, what is the main function of that recursive code? Like, what exactly does it do? What problem does it solve as?
It prints a string. This string,
Okay,
instead of using the simple way for loop for I0, then less than
okay,
string I plus plus, we use a recursion to print it. We
okay.
each character we could have just used percent s
So it just duplicates strings, right?
no, it does not duplicate. It prints them. It
Okay,
prints. So it prints the string character by character. That's the
okay.
function.
Yeah, thanks very much.
So the function we just did now, um, we just need to print the string recursion, and then to pass in the string, we need to make char star recursion a parameter, and then the length the I. So let's move on. No, let's check other examples now. So let's say we need a code to should we do that? Okay, We need a code to print the number 10 through 1 on separate lines. Number 10 to 1 on separate lines. How can we do that? How can we print the number 10 to 1 on separate line? This is one way we can do that. We can use a loop. Let's implement a loop for I equals to 10. I is greater than equals to 1. I minus minus. So this is the loop. We can use this to print it. What do? We print f percent b an integer I. So this here should print the numbers 10 through 1. Let's put it on a new line. Yes, this prints the number 10 to 1 with a for loop. Now let's try this also with a recursion. How do we start? Let's see what we did here. This was our initializer. This is the case, and this is the iterator update. We will be doing this same thing also. So let's try the recursive function now. First, let's declare the function. Let's call it, since we are printing, we are not going to return anything. It is void. Call it count. Let's say count down. Takes an input of n, the number. So that's it. It takes an input of n. So let's just call it from here. Let's call it count down. Let's say I. Then let's put I equals to 10. So we are calling this function with n as the argument. So now let's work with that function now. How do we start printing it from 10 to 1? That is from the number they gave us up to 1. So let's do that. First, we need our initializer. This is the initializer. It has been initialized. We need our case, our base case, our condition. Now let's check condition. What is the condition? The condition is if the condition is the printing 10 to 1. That is while n is like why this n is greater than 0, because 1, the last input is greater than 0. So we can say this thing is like the case is like n greater than 0. So yes, if n is greater than 0, then what do we do if n is greater than 0? We print n percent b line, and then we print n. So yes, we pass the 10 to it. What will this do? Let's run it. It will print 10, and then that's it. Because we say if n is greater than 0, print f n 10. So we are not done yet. We need to print 10 to 1. So what do we do? After printing 10, we need to do what? We need to reduce it by 1 each time. So we do this. We call our function again recursively. With what? It takes n. But now, instead of passing n, we minus n from 1. So this will reduce n each time it calls itself, and each time n is greater than 0, it will print it. So let's see. Yes. So we've done it. The base case and the initializer, we initialize the function with 10. Then it checks if the 10 is greater than 0. If it is, it will print it. If it's, then it will reduce the n and then call its function again. And then each time it will check always that n is greater than 0. So we can check with 100. And let's see. It works also. So does anyone have any question regarding this? Any question regarding countdown? Exclusive, which side are you lost? Let's try to recheck. It's exclusive there.
You already explained it. You already explained it.
All right. So I guess you can check another implementation. I'm sure you should have seen the factorial principles. Now, what is a factorial? Everyone knows what factorial is. In a calculator, let's say 5 factorial it will be 5 factorial will be 5 times 4 times 3 times 2 times 1. So factorial is multiplying, like multiplying the number, then minus the times the multiplying the number, then times minus the number, then times minus the number, times so this looks already like a recursive function. This has the natural recursiveness in it. So how do we implement it? Let's call the function its factorial. It will take an argument of n, right? Take an argument of n. So let's use from here. Let's change this factorial. Let's initialize it with I, which is 5. Now what this is let's just check with this. So factorial I, we've initialized it. Now we need the base case and the execution and the iterator update. So the base case now, what will be the base case? Let's check here. It seems this is all running until it reaches 1. It keeps multiplying until it reaches 1. So let's set a base case of if n is equals to 1. That will be our base case. Then what will happen if n is equals to 1? We return 1. Remember, we are returning the multiplication of this. So this is going to be returning an int. So we return 1 once we have n equals to 1. This will be our base case, that the function should stop calling itself once it is 1. And then we continue. What happens next? If n does not equal to 1, then what do? We say n, which is 5, will be what? Times n minus 1. So that's the thing. N times n minus 1. This is what just like n times n minus 1. Minus 1 on each column. This is the this is what this looks like now. This is the representation, n times n minus 1. So let's try to do that. So if n does not equal to 1, that is, it is still greater than 1, then what do? We call this function again. But before we call the function while multiplying it with the current number. So we call the function with n times what? Factorial n minus 1. What does this mean? Let's say an input of 5. It will say what? It will say 5 times factorial 5 minus 1. And then that will be 4. And to call 4, then 4 is not 1. So it will be again 5 times 4. Let's just round. So the first one, 5. Then 5 does not equal 1 in our base case. So it will be 5 times what? The factorial of what? 5 minus 1, which will be 4. And then what is the factorial of 4? It is also not equal to 1. Then it will be what? 4 times factorial of 4 minus 1, which will be what? 3. So what is the factorial of 3? It is also not 1. So it will be what's 3 times factorial 3 minus 1, which will be 2. Then this up to 1. Once it is 1, it will return 1, which we will multiply it with the final 1. So let's try and find it works. So running the okay, we did not print our result. Let's print the return. That will be percent D. So let's run it. Yes. So the factorial of 5 is 120. This is how it works. Factorial of 5 is 120. Let's check another number. Factorial of 10. 362 8800. So I hope this also was clear. Does anyone have any question regarding factorial? Any question on factorial? Or should we continue? Let's continue. Should we have another example? Or is this enough? I hope this is understanding enough. Or should we have another example?
Please let's do examples if you don't mind, sir.
All right, let's do just one more course of time.
Hello.
Yes.
Hello, please. Sorry to interrupt, please. I just want to ask a question, please.
Yeah, no problem.
Please, I don't know if there's any code 12 member in the house.
Code 4 is there any code 4 here?
But I'm actually looking for who to do the body call with. So I don't know if anybody is available.
I don't think anyone of code 4 is here.
Oh, okay. Thank
All
you.
right. Yeah, you're welcome. So now let's check another function. Fibonacci series. Let's see Fibonacci series. What's a Fibonacci series? Let's quickly check the web of that. Fibonacci series. Sequence series. This is the Fibonacci sequence. Let me copy this. So what is peculiar here? Let's try to find a relation. We can see, let me clear this. We can see 0, 1, 1. This here is the usual first 3, or let's say first 2 of Fibonacci sequence. It starts from 0 and 1. And what does it do? Starting from 0 and 1, each element after is a result of adding the previous element. So to get this next element, it should be 0 plus 1, 1. To get this next element, it will be 1 plus 1, 2. To get the next element, it will be 2 plus 1, 3. To get the next element, it will be 3 plus 2, 5. 5 plus 3, 8. Then continue. So now, what's the relation in this thing? It's like we're saying, like we are adding the previous number, the two previous numbers together. And what is the two previous numbers? That would be, let's say the current number is 2. The two previous numbers will be n minus 1 and n minus 2. That would be the two previous numbers. So let's see, what will be the previous number of 2, which will be 2 minus 1, I think that will be 1. 2 minus 2, that would be 0. Remember, this is like they are represented like a string. So it should be 0, then this is 1, then this is 2, then this is 3. Something like that. So the two previous numbers will be n minus 1 and n minus 2, and then we add them together. That's what is Fibonacci sequence is doing. So this, to find this place, we need to check the previous number, check the 1, and that's 0, 1, 2. So this place, this particular index here is what? It is 3 if you look at the way strings are represented in C to be 3, because this will be 0, 1, 2, 3. So what do we do? 3. 3 minus 1, it is 2, and this is 2. 3 minus 2, it is 1. So what does it do? It will add this 1 and this 1 to give us this. So this is the sequence, and this is the relation or the something like that, the format of this Fibonacci sequence. So now let's try to implement it now. We have int Fibonacci, int n. So what do we do? Let's try to initialize it first. That's the first thing always we should initialize. So we have int. Let's say we are trying to look for the nth number in the Fibonacci sequence. Let's find the nth number in the Fibonacci. So let's find the 5th number in the Fibonacci sequence. So we call it with Fibonacci 5. So this is our initializer here. If you initialize the recursive function. After initializing, what do we need? We need a base case and we need our iterator update. What will be the base case? Let's check here. What's the base case? It seems, this thing we are finding the nth element. So we are going to be starting like from 5, from any top of element. We are starting from top down. So starting from top down, what is the check here? The last thing we are saying is 0. So I think this is the base. 0 is the base. So how do we check for that base? We need to see if n is less than or equal to 1. That is, if n is at this 0 or 1, these two are just the base case. Because Fibonacci series, it starts from 0 and 1. They don't start from 0, they start from 0 and 1. So if n is less than or equal to 1, that's our base. This is our base. Then what do? We return n. Return n. That is, if it is less than or equal to 1, we return 1. Let's say the n was 1. We say we should find the 1th. We are finding the nth number of Fibonacci series. So let's say we are finding the 1th number. This is the 1th number. So this thing we just check straight. Is n less than or is it equal to 1? It is equal to 1. So we just return n. It will do it straight. And let's say we are finding the 0th number. The 0th number is 0. So is it less than or equal to 1? Yes. So just return 0 straight. So this is the base case. But if it is, let's say, greater than that, it is all these other numbers. What do we do? We say else. Please, you guys give me some minutes. I'm coming. Few minutes.
Okay, hi everybody. I want to believe we are really enjoying the class.
So sorry, guys.
Seriously.
Yeah, sorry. Let's continue. So Fibonacci, yeah. So now, if we've checked for the base case, we need else if it is the base case not true yet. So what do? We call our function. We return. What are we returning? Remember from here I said to get the nth element or something like that. Let's say this is the third element. To get the third element, we say 3 minus 1 plus 3 minus 2. 3 minus 1 will give us the second element. then 3 minus 2 will give us the 1th element. So to get the 3rd element now, that would be the 2th element and then the 2nd element and then the 1st element. This is the 2nd element, 1, and then 1st element. 1th element, don't let us see first, 1th. This is the 0th. So this 1th plus 2nd or 2th, let's just put it like that. So 1 plus 1 will give us 2, which will be the 3rd element. Because we are starting on 0, 1, 2, 3, 4, 5, 6, 7, and like that. So we return what? We are returning the addition of Fibonacci n minus 1, Fibonacci n minus 2. So it will call this one separate, call this one separate, and then it will now add the 2 together. So that's n minus 1, n minus 2. And then after calling them, it will add them together and give you the nth element. So let's try to check this now. Let's print this and this. Fibonacci 5th. Let's just check what's the 5th number. 1, 2, 3, 4, 5. This 3. Let's confirm that. Let's run it. Wait. Okay. 1, 2, 3, 4. Oh, sorry. 0, 1, 2, 3, 4, 5. This is the 5th number. It starts from 0, remember. So the 5th number gives us 5. Correct. Let's check 6, 7, 8, 9. Let's check the 9th number. 9. Correct. It gives us the correct output. Let's check the 8th number. 21. Correct. So it gives us the correct output. So I hope this one was understood again. This is what all recursive function is about. The initializer.
Sorry, sir.
Yes.
I've had my hand up.
Okay, you can talk. Just talk.
I didn't want to. Okay. When I didn't quite understand the base case, the whole idea about the base case and how you set up the base case.
The
I
base
just want to
case,
stop. I had my hand up.
the base case is like the condition. You don't want to run a loop forever. The condition or the in a for loop you say you have an initializer and then the condition and then the iterator. So the condition is what you keep checking on each loop to make sure that it does not run forever. That it stops at a certain point. Now to find the base cases are usually the base of whatever you're finding. The base in like the base like the either the final the least output or the least return or something like that. But in this Fibonacci case, the base here is 0 and 1. The Fibonacci starts with 0 and 1. 0 and 1. So that's the base case. 0 and 1. That's why we say if n is less than or equal to 1, we just return 1 and then we return 0. Or if it is less than if it is 0, then it is also less than 1, then we just return 0. So
Okay. Okay, so like the base case, like you said, is like the condition so that it doesn't keep running forever.
Yes,
I thought,
yes.
from the way you're saying it, I almost thought the base case was arbitrary. It was something that you said. For example, you could choose to set the base case with, let's say, 8 and 5.
No.
Okay, that wouldn't work.
Okay. No,
thank
because well, let's give it a try. It won't give you the correct answer because this will just be maybe your own Fibonacci, your own sequence. If you want to create your own sequence, then yes, you can use 5 and then create your own sequence and all that. But for the Fibonacci sequence, it is 0 and 1. So the base is like less than or equal to 1. So that's why we use 1. And that gives us
I think I understand. Thank you.
All right. So maybe we should even work through. Maybe we should walk through one of these. Okay, let's say the third number 0, 1, 2, 3. This is the third number 2. Let's pass it in and let's work through it. So 3 is 3 less than or equal to 1? It is not. So it won't do anything here. It will do what? It will call it again Fibonacci n minus 1, Fibonacci 3. Let's try to find Fibonacci 3. So Fibonacci 3 minus 1, that would be 2. Then plus Fibonacci 3 minus 2, 1. So what is Fibonacci 3 and Fibonacci 2 and 1? We check the function again. On Fibonacci 2 now, Fibonacci 2 we do what? 3 less than or equal to 1. It is not. 2 is greater than 1. So on Fibonacci 2, we call this recursive again. On 2 minus 1, which should be 1, plus 2 minus 2, which should be 0. And plus this other one we call the 1. Fibonacci 1 now will return, since it is less than or equal to 1, it will return 1. So this is the return here. We are not calculating any recursiveness again. So on this 1 and 0 now, on 1 and 0, is 1 less than or equal to 1? Yes, it is equal to 1, so it will return 1. Then we add it with 0. 0 less than or equal to 1? Yes, it is less than 1. So it will return that n, so it will return 0. Then plus the other 1. And this will give us what? 2. This is called a trait element or number. These are the recursiveness works. So I hope this was understood as well. Should we move on now? So that's all about recursiveness for now. Let's so in what situations should you implement recursion?
Yes.
So let's see that now. Like where should I start recursion or where should I just use ordinary loop? Hello? I can't hear you. Sorry, can anyone hear him?
I can't hear him either.
Can't hear you. So let's conclude. So when should you implement recursion or when should you just do loop? So to implement recursion now, it's a useful tool in solving certain types of problems. Let's check what type of problem 1. Problems that can be broken into smaller sub-problems. So problems that you can divide, usually problems that take like a divide and conquer algorithm and all that. So problems that you can break into smaller sub-problems. For example, the problems that involve traversing a tree or a graph, it can be broken into similar sub-problems. A tree is, I don't know if you are there yet, it's like an algorithm that keeps like branches. So it involves division and you might check on the tree algorithm later and that. So you can use recursion for problems that can be broken into smaller problems. Then there are some problems that have natural recursive structure. If you remember the factorial that we just did with, it has like a natural recursiveness structure because in itself it looks like it's just calling itself again. So, for example, problem of computing factorial of a number that can be naturally solved recursively by computing the factorial of the number minus 1. You can see number problem that can be solved by recursively computing like the factorial. Something that like minus 1 divided by 1 or something divided by certain something. And then multiplying the result by the number. So this is what we did in the factorial example. Number 3 now, problem that can be solved using a divide and conquer strategy. This is almost the same as this one. These are problems that can be broken down into sub-problems. For example, a problem that involves sorting an array, yes, it can be solved possibly by dividing the array into smaller array, then sorting the sub-arrays, and then merging the sub-arrays together. An example will be merge sort, because a merge sort is a recursive function. And pick that up, but maybe not. So a problem that can be divided and executed or something like that, divide and conquer strategy. 4, problems that are naturally defined in recursive terms. They are defined naturally in recursive terms, like the Fibonacci series numbers and many other mathematical problems. So these are the situations where you should implement recursion. Let's look at the situation where you should not implement recursion. There are several problem situations where you should not even try recursion. Let's see problems that have simple solution. For example, the first example I did, it is just an example. You should not try to print recursion or print a string with recursion. I mean, you can just quickly do that with a for loop. Right? So that was just an example. So problems that involve iterating over an array, a list, or a string, it can be solved easily with a loop rather than recursion. Number 2, problems that have large input size, you should not try it, because recursive is just for quick dividing and solving or something like that. You should not try it with large size, because it might take just forever. Recursive function, they use stack memory, and if the recursive function calls are too deep or too large, it may cause the stack overflow, and then it can also be less efficient than a iterative solution for large input sizes. Number 3 now, problems that are performance critical. Because the solution can be less efficient than iterative solutions in terms of time and space complexity, so they can be the loops are faster than loops. That's the thing. Recursive function is not usually fast, it's not usually efficient than iterative solutions like loops. So if performance is a critical concern, it may be better to use iterative solutions like loops instead of recursion. But recursion are just like it is simple to implement, and what can I say? It requires less. Let's just say something like lesser code or something like that. You can just quickly build a function, and instead of making the several loops inside the function, you can just call itself another. So number 4 now, problems that have a high risk of stack overflow. We've talked about these large input sizes. If the recursion is deep or the risk of stack overflow is high, you should not try recursion, because this can cause the program to crash, unreliable, or limited autonomy. Number 5, problems with not clear base case. Problem that you can't just find the base case, because you can't find base case in every problem. So because the recursive function needs that base case, it needs it to be clear. If it is not clear, you can't find the base case, you should not try recursion, which is the point where the recursion stops. Because if you don't have a base case, then the recursion will keep going indefinitely and leading to an infinite loop. So I think that's all for recursion. Perhaps anyone have any question? Let me stop sharing the screen. Does anyone have any question? Is David there?
I'm here, sir.
All right. Is there any question, or should we? I will leave it here.
Sorry. Okay, I think nobody has a question. If they have questions, they would
Alright.
have asked.
All right.
Yes.
So that's all with recursion, and perhaps I give if you need to check more on recursion, I will have a link dropped.
Okay, sir. So I will inbox you and we'll talk about the success of the program. Yes, sir.
All right. There's a link in the chat if you need to read more on recursion. If you check it up. So thank you guys. That's all.
Okay. Excuse me, sir.
Yes.
Somebody's hand is up, so I believe she might have a question or something to say.
Oh yes. Blessing.
Blessing, speak.
You can unmute yourself.
Hi, good evening, everybody.
Good evening.
Good evening, Blessing.
Yeah. So, going through all of this, I would say the lecture was quite clear and it helped me understand recursion a bit better, right?
Yeah.
But then when we stumble upon challenges, can we reach out to you? Like, how can we reach out to you to be able to help us out? That's when we're practicing.
When I'm on WhatsApp, probably David can share my contact or.
Okay, are you on the group? Like.
Yes, I am on the group.
Okay, Blessing, we can't hear you again, but I will tag him in the group, and so that everybody can have access to him.
The group David created. Hello, can you hear me?
Yeah, we can hear you. You were out for a while.
I wasn't here. Yes.
Okay, so I said I'm going to tag him in the group so that everybody can get to know him too, in case you have any issues.
All right, thank you so much. We're grateful.
All right.
Okay.
Thank you, guys.
Okay, sir. So we are very, very happy to have you today, and I can tell everybody here can also tell that your class was very enjoyable. Man, I got to understand this in another different way. So I'm grateful, and on behalf of everybody, I say thank you.
No problem. Thank you. Goodbye.
Okay, sir. Bye. So I want to believe everybody enjoyed the class. Yeah. So if you have any more questions, you can. I will tag him in the group so that I can also inbox him too. And then the slides is going to be available. I will ask for it, and yeah, I will make that available. And also, I'm going to put up practice problems on that in our repository. So later on, maybe tomorrow, you can go and synchronize the repository and try to attempt your tasks. So does anybody have a question or anything to say? Anybody? Okay. Blessing, please.
Yes, I just wanted to say thank you so much for all you're doing for us. This is really helping out. Thank you. We're grateful.
I appreciate you too. Okay, thank you for being here too, because it wouldn't have been successful if you were not here. So I want to thank everybody, and we look forward to having more classes like this. So this is the second person we brought, and he took us on the things we had in the intranet. So perhaps in our next class, I'm going to bring somebody not to come and teach us any of this, but to come and have word with us. He's a professional, yeah, an experienced person. So I believe by the time he comes, we might want to ask him questions about how a typical work day is in being a software engineering, and any questions at all about the career path that you've chosen, or if you have questions on what specialization you would like to take in our third sprint, and you can ask him questions and stuff like that. So I don't know when I will bring him particularly, but he's not always chance. He's mostly chance on Sundays. Yeah. So I don't know if it is actually okay for us to host that kind of session on Sunday, but I will see how I can also bring him outside the weekend. But for now that he's saying he's only comfortable on Sunday, I want to ask us, are we comfortable with that? Should we have that kind of session on Sundays? Okay, Yeah, okay, hello.
Yeah. Good evening, everybody. So me, personally,
good.
I feel that if, as it is a learning series, we should not. I know I'm speaking for myself anyway. I think the restriction of maybe not using Sunday as a learning day, it doesn't really count because we know what we're actually going to gain that day. So for me, using a Sunday for a learning series is not bad.
Okay, great. Okay, thank you very much. And I'm looking at our chat session now. I'm seeing no problem. Yes, Sunday night might be okay. We can make out time for it. We are the ones benefiting. Okay, so everybody is on a yes to it. Somebody said I think we should use weekends for revisions. Okay, that's all. That is also good too. So I'll see how I'm going to work it out so that we can have such person come speak with us, and then afterwards we will start the part of having one of us to also take us on 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 sessions. So I might, so everybody should just prepare. I will drop a topic and ask everybody to prepare, and at the end I'm going to choose a particular person to take it, or I might pair you for the both of you to take. So when that time comes, I'm going to tag whoever I'm going to choose to take us on sessions. So this is going to help us to also do more research on a particular topic and also build our confidence in that particular area. So I hope when I call on this, you are going to respond accordingly. So for now, I think that's all. Nobody has anything to say. So I want to say thank you for being here, and I look forward to us having more of this. Okay, so somebody said we will try. Great idea. So guys, you can unmute your mic and say good night to yourselves.
Good night, Mr. David.
Good night.
Good night, everybody. Nice learning with you guys.
Yeah, nice learning with you too.
Same here.
Good night, Mr. David. Please, can we push the small tasks that we've done?
Yeah, of course, push. I'm reviewing every day, every time. I'm always there.
Okay, so it's not until we push, we complete all the tasks up to task 11.
No, of course not. No, of course not. If you do number one, you can actually push. You do number two, you push. I'll still be talking and I'll giving you your.
Sir David.
No. Yes, go on.
Yeah, for my own task, the one I submitted, you made some complaints. I did not understand.
Okay, what was that?
You said I should use one function rather than two. For instance, for that one that prints 14 for 10 times.
Okay. I remember that. Okay, I think what I was saying was I think you created a function and then you called the function again, or perhaps you wrote the function, then you gave
I wrote two functions, one to print 10 times, one to print 14 times.
Okay, yes, exactly. Okay, so what I meant was instead of doing it like that, one for that and one for this, that you just if you can create it at once. Okay. Do you understand?
I understand. I was trying to make it simpler. Anyway,
okay. Yeah, it's true. I was just trying to say if you can cut it down a bit and give it like one block of function.
Okay, no problem.
Okay, it was just for you to try another thing. Okay, so you what you did was actually good, but this was just for you to try another way too. Okay.
Okay, noted.
Okay, no problem. So for those who have not done yours, so you can also go on to completing your tasks, and if you have not forked the repository, you go ahead and fork the repository. I'm having 40-something fork repository, but I'm just having, I think, 13 pull requests. So others who fork the repository and did not do anything, I wonder what you are doing. So I'll commend the likes of Gibson. Gibson has been doing a great job. Yeah. Osireme Abulu, yeah, she has been doing good. I mean, in completing our tasks. And then Apple is not. Apple has left. Apple has been trying. Najib, of course, I can't forget that. Najib has been contributing even to the main material. So I may not be able to call everybody's name, but I appreciate you a lot. So for those who have not done their tags or who have not forked the repository, please go on. And also the materials are also there. You can go through it again. So I want to thank everybody again for being here. Good night, guys. Good night. You can unmute yourselves and say good night, please.
Good night.
Good night.
Good night, oh.
Good night, Boluwatife.